for example 3, it asks us to solve the right triangle using the law of sines, where the measure of angle A is 50. The measure of side length A is 50. Measure of side length B is 100, and the measure of angle A is 50 degrees. This given info satisfies side-side angle. So if we are trying to solve for the measure of angle B, we can take the sine of A, which is the sine of 50 degrees, and divide that by the side length of A, which is 50, and set that equal to sine of B divided by the side length of B, which is 100. Now to solve for sine of B, we need to multiply by the denominators. This becomes 100 sine of 50 degrees equals 50 sine of B. Just dividing by 50 tells us that sine of B equals 100 sine of 50 degrees divided by 50. When taking this into our calculator, we get sine of B equals 1.53. Yes, of course, in order to solve for B, we have to take the sine inverse of both sides. However, the sine of something the sine of an angle should never be greater than 1. So this is not possible. Because the sine of an angle is always less than or equal to 1. And that is just thinking back to when we drew our sine and cosine graphs. It went from -1 or -1 to +1. So if we have an angle, or the sine of an angle that is greater than 1, it's not possible. So all we have to write is no solution. Now looking at our next example, example 4, it says solve the triangle using the law of sines, where the measure of angle, or the measure of side length A is 30, the measure of side length C is 42, and the measure of angle A is 37 degrees. This given information satisfies side-side angle again. So in order to find the measure of angle C, we take sine of A, which is 37 degrees, divided by 30, and set that equal to sine of C divided by 42. To solve for sine of C, we need to multiply by our denominators. This becomes 42 sine of 37 equals 30 sine of C. So dividing by 30 on both sides, we are left with sine of C equals 0.8425. And then taking the sine inverse on both sides, we are left with C equals sine inverse of 0.8425, which that is equivalent to 57.4 degrees. So we can write 57.4 degrees. So now we can easily find the measure of angle B. Measure of angle B is just equal to 180 degrees minus 37 degrees minus 57.4 degrees. So the measure of angle B is equal to 85.6 degrees. So now to solve for our missing side length of B, you can take sine of 37 over 30, which is the angle A and side length A. Set that equal to sine of 85.6 degrees divided by b. And to solve for b, we are left with b equals 30 sine of 85.6 degrees, all divided by sine of 37 degrees. Kind of just did two steps in one, but as you get more comfortable with these problems, you'll be able to do the same. So then b equals 49.7. And now we have found all of our side lengths and missing angles. 49.7. So looking at this first triangle, we know the side length of A is 30, side length of B was 49.7, and side length of C was 42. The measure of angle A was 37 degrees. The measure of angle B was 85.6 degrees. And the measure of angle C was 57.4 degrees. The first angle we found was the measure of angle C, and that was 57.4 degrees. And other possible measures for angle C include taking 180 degrees and subtracting off 57.4 degrees, which gives us an angle of 122.6 degrees. So now we have to ask ourselves, does this work? Would an angle of 122.6 degrees make sense? So given our angle A, which was 37 degrees, and that was given, and if we add 122.6 degrees, which was the measure of angle C, that equals 159.6 degrees. Since 159.6 degrees is less than 180 degrees, we can tell ourselves, yes, there is still some left for angle B. So since 159.6 degrees is less than 180 degrees, we can say yes, there's still enough of an angle. There's still enough degrees left for an angle B. So we can find measure of angle B by taking 180 and subtracting off the 159.6 degrees, and that gives us an angle of 20.4 degrees. So think of the second triangle. We have the measure of angle A will still be 30, the side length A will still be 30, the measure of angle A will still be 37. We just found the measure of angle B would be 20.4 degrees, and the measure of angle C would stay the same at 122.6 degrees. And the side length C was also given, so side length C will remain 42. To find the side length of B, we can use the law of sines. So for the second triangle, we can take sine of 37 over 30 and set that equal to sine of 20.4 over B. And then we know B equals 30 sine of 20.4 divided by sine of 37 degrees. So then, using your calculator, calculating this out, B equals 17.4. So the side length B would equal 17.4 in the second triangle. On the quiz and on the test, there will be an ambiguous case where you will need to solve the triangle two different ways. There will be a second triangle, so please get used to determining when there would be a second triangle and also how to find the side lengths and angle measures of that second triangle.